Yeah, let me go ahead and just record it. I'm recording it now. So
Okay.
I'm not sure where it goes, but here we are. I'm recording it.
All right, Riley just joined us, so 3 of us are in the same room.
Cool. And I'm going to put it on mute until I have something to say that's useful.
Is it recording now?
It is, yep. Upper left-hand side, you should see a button that says record.
All right, can you see our
Yep,
screen?
Alexa solutions for CW students. Yep, I got it.
Perfect. Well, I'll get it started then. The door. Our presentation is covering Alexa solutions for CW students. Our team is called CW Connect. Our client, Bob Rapp, is an expert in hybrid cloud architecture, and he spent about 15 years at Microsoft, a few years at IBM, and has successfully started and co-founded a few startups, as well as this current one, Hybrid Cloud Gurus. And our other client is Andreas Bowman, who is the VP of Operations at Central Washington University, and also the Chief Information Officer. And our supervisor is Dr. Sillard Voida. So just to cover our table of contents real quick, we're going to go through project overview, requirements, description and analysis, structural design, development tools, project structure, test scenario, budget, and conclusion. So just to introduce our team real quick, my name is Tyler. I am the team leader, and I'm also one of the developers. My name is Patrick, and blah, blah, blah. Is Jack here? Yeah. Jack,
Sorry, I was muted. My name's Jack, and I'll be working with hard.
I'm Emily Bodenhammer.
And I'm Riley Crawl. I'll be doing testing and other development.
So for what our project is doing, so we are working to build an Alexa skill called C3, which is short for Central Campus Connect, and it's going to cover 3 key features. The first one being base functionality, the next one is authentication, and the last one is personal data access. And what the school is going to work with us to do is integrate this into the new dorm, which is Dugmore Hall. And the goal of this is basically to create a tool that will ease student life. So different information that they can look up on the CW website will be readily available in this application. So for example, if they're wondering what time the circ is going to close for food hours, they can just say, hey Alexa, what time is the circ closing tonight? And it'll immediately give them a response, which will make it super easy to find information that they would otherwise have to search through the school's website for. Our primary users are going to be on-campus students, so students in the dorms, and our secondary users would be off-campus students and possibly faculty in the future. So now I'll pass it on to Emily to talk about the requirements.
Thanks, Tyler. So in order to accomplish this goal of making life like a
Hey, Emily, can you speak a lot closer to where I can't hear you? So
Can you hear me better?
lots better. Thank you.
All right. So in order to accomplish this goal, the first requirement that will need to be implemented into our software would be answer frequently asked questions by Central Washington students. The next requirement would be PII protection. PII stands for personally identifiable information. This information for our software would be the student's student ID number and phone number. The last requirement is money transactions. So we would want the students to be able to add money to their connection cards and to also look at the balance that they have on the connection card. So in order to accomplish the task of getting the frequently asked questions from the students, the first thing that we would do is we would create a survey as a team and go to the dormitories where the students are and ask them to answer our survey or to just ask students at Central in general. The next thing would be, in order to protect students at PII, would be to create some authentication steps. The first step would be the student, when they say their student ID number, we would then call the database. The database would find the phone number that corresponds to that student ID number, which would then send a SMS message to that phone number, which would include a 4-digit PIN. The user would repeat this PIN to Alexa, which would then be encrypted. The next step would be to make Alexa learn voice recognition. How we would do that would be Alexa already has an option for creating a voice profile. We would use this voice profile to be recognized for the user when they first do the authentication step. That way, any other time they try to use our skill, we'll recognize that the user is the user using the voice profile. So here is the layout of our low-level design process. So first, we would create our skill using the Alexa Skill Kit. The Alexa Skill Kit requires a server, and that server we will be using will be the AWS Lambda server. This Lambda server allows us to run code through it. So the code we would be using would be a Python code. That Python code would be able to query the central databases to get the student's ID number and profile and phone number. This would then lead to the authentication step, which would then lead to our code querying our own database that we created or back to the central database, depending on what our user asks Alexa or whatever command they ask. The code would then quit the whole skill when the user says, please quit C3. This is our high-level design process, how our skill would work. So first, the user opens the skill. Alexa asks the user for their student ID number. If when they give the student ID number, they will then go to the authentication step. If the PIN that was received is correct, the user will ask customized questions or commands to Alexa, and Alexa will perform these questions or commands. This can be repeated as many times as the user pleases until they can end. An alternate route is if the student does not have an ID, we could just make the user ask general questions that doesn't require us to use any PII. Now I will pass it off to Patrick, which will be Tyler.
Yeah, I'm just going to cover Patrick's part for now since he's not able to make it to this meeting, but he'll be doing this part in the presentation later today. So our development tools, the device that we're going to be working with is the Amazon Echo Generation 3. The programming language that we're going to use is Python because it's very flexible and it has a ton of applications. It's super easy to learn, so we just thought that would be a great language to work with. Cloud9 is the IDE that we're working with. AWS, which is Amazon Web Services, owns this. And it's the platform that they use to incorporate code onto their databases to host it. AWS Lex is their database that they use for Alexa. And so anytime Alexa is called, it sends a query over to the AWS Lex database, and it responds with a text, or it converts basically voice to text so that a program can analyze this text and do something with it with handlers. AWS Lambda is basically the call back from the software back to the Lex. Anytime that the application is called, it will use a Lambda call and call the Lex database. Twilio is an application that we're going to use for our SMS PIN or authentication. And so what it's going to do is anytime that the user is doing their first time setup, Twilio will send a text message to the primary phone number on the student's account, and that will basically help us with authentication. And MariaDB, I believe, is the database for Amazon Web Services or something. Patrick knows. So the pros and cons to AWS, a couple pros: easy integration with Alexa devices. Connecting front end to back end is fairly simple. There's not a lot of code required. Serverless computing, we don't have to host any of our code. AWS will do it all for us. And we can focus on skill development rather than worrying about a lot of front end development or things like that. Some cons are that AWS Lambda and Twilio are paid services. Lambda is free for the first 1,000,000 calls, but costs after that. And Twilio is about 0.0075 cents per SMS message. And so with 10,000 students, that could rack up a large cost. Foreign development environment, we are just not familiar with AWS. This is our first time using it, and so it's going to take a while just to get used to the experience with it. Our development strategy that we're using for this project is the incremental process model. Like Tyler said in the beginning, we have 3 key features: base functionality, authentication, and personal data access. I'll pass it off to Riley to talk about the timeline.
So for how we're going to go about this project, we're going to start with some research and practice over winter break.
And could you talk closer to the mic? Sorry about that. Can't hear you guys.
Super far away. So for the timeline, we're going to begin by doing some research and practice over winter break to teach the people who don't quite know Python, and to get used to the whole AWS. The actual project will begin January 3rd, and the end of it will be by March 13th. And this is the actual graphic showing our plan and timeline. As you can see, we start planning the base functionality the first week of January. Once we get a good idea how we want everything set up, we'll have about 4 weeks developing the base functionality. That's just to make sure we have everything set in stone. While we're developing the base functionality, we'll also be planning the phase of getting personal data access, making sure that we actually can access school databases and things like that. Once base functionality is finished, we'll go into testing of the base functionality, but also at the same time, we'll start development of authentication to make sure we can actually safely access all this data. And we will end up finishing our project by March 13th. That will be after about almost 3 weeks of testing the whole product. For functional testing, we would like to verify that we actually get results from our functions. We're going to make sure that all of our results are valid, making sure that we get what we wanted to get from our functions. And then at the end, we're going to have some security testing to make sure that everything's done safely, just so when we actually implement this into the public, everything goes smoothly. For user testing, we're going to get groups of students primarily. We'll start with students from the new dorm. We'll probably just hand out some candy and bribe people to help us test. This will be in order to see, like, did we get the correct questions? Do they understand, or is it an easy to use product? And see like what kind of students would actually use this product. Next, we'd probably go out to other students that could just install this on their own personal Alexa devices. So this could be off-campus students or other students in other dorms, and see how this works just if they're not in the environment it's already implemented in. And we'll do these tests kind of blind to the user, so they don't know what to do going in, so we know exactly what their experience will be if they first install this product. So just a common test scenario we'll go through with that. The user would come up to Alexa, would have them access their skill, and we would ask them to add funds to their connection card. This will prompt the C3 to send an authentication code to the account. And during the test, we'll have a fake account and probably use one of our phones. And then once they have successfully gone through, it'll confirm that it has added funds to the account. All this will be done, and then we'll be able to see what the user's thought process go through this situation.
All right. The budget for us is we're using the AWS Lambda and Twilio applications. AWS Lambda currently costs 20 cents per million requests. Granted, though, the first million requests per month is free for people who are using the service. So technically, if we don't go over 1 million per request per month, we will never have to pay for AWS Lambda. The biggest issue right now is Twilio costs about 3/4 of a cent per text message sent. As we will only be using this for the first time a student activates it to set up their profile, password, and other information, we approximate that the first month will only cost around $100. After that, the average monthly cost will be around $25. The other big expense that we have is having the hardware set up for the new dorms. We believe that around 5,000 devices will be needing, sending us around $115,000. In conclusion, we are working towards a goal of making a complete skill for Central Washington University students. We're working with Bob, who is a very excellent programmer. We have a really good timeline, as Riley mentioned in the previous slides, that show how we plan to adapt everything over time and test. We will be able to hopefully answer frequently asked questions from CWU students, as well as transfer money into their accounts via the Amazon skill. We also have many tools and strategies to help us out along the way, including Cloud9, AWS Lambda, AWS Lex, Trilio, and encryption. Thank you all for, here are our references. Does anyone have any questions for us in the?
So good job, guys. I've got a few comments. Can you hear me okay?
Yeah.
So first of all, good. I like the presentation. I think it's hard to misunderstand. There's a few things there's a few kind of factual things you might want to check. So the first one is that Lex is actually not a database. Lex is a trained artificial intelligence model that turns, in this case, a WAV file, so the recording of Alexa as a device or the Echo device, into text, and then the text is evaluated against a semantic set of rules. So there probably is a database in there somewhere, but it's really you might call it an AI service that turns voice into text. Okay.
Okay.
The second, from a design point of view, is you guys might want to consider looking at the Amazon. Amazon has a service called SNS, Simple Notification Service, that sends text messages. Twilio is a good service. It might even be cheaper, but we might have a benefit. You guys might want to do some research to see if we want to keep everything on AWS, because it would make our security a little bit easier.
Yeah. Okay.
The third one is I'd probably put in there some sort of warning to say we're going to also work on making sure that we have some alarms and triggers so that we don't exceed budgets, right?
Okay.
Just a note, probably you're going to want like a Cloud Watch or a Cloud Trail event to monitor usage and authentication. And I would maybe do a slide that shows from the phases, maybe just show a phase that says basically you're going to build an initial skill, which is just the FAQ. Everybody can use it. Anybody in the world could use it, frankly. If they want to know answers about Central Washington, that would be a non-authenticated service. And then the second thing you're going to build is an authenticated service, which has a one-time enrollment where they would establish the relationship between their student number and their mobile phone, right? And then they would train it. You also need to make a decision about where you want to put the Alexa devices, because at the moment, the assumption is it's going to be in dorm rooms. By the way, that may not be a good assumption, but it may be, we may want to say it has to be in a secured location, because I don't want these to wander off somewhere, right?
Okay.
And we don't currently have any plan to watch them with cameras or put them in the cage or anything like that. So just make sure you put an explicit design requirement in that they're going to be secured somehow in dorm rooms or faculty offices or something like that.
Okay.
Yep. And then a couple of things. I think your numbers are way off on the price of a Gen 3 Echo Dot. I think your prices might have come from Black Friday or Cyber Monday, but I think they're more like $50. You should go look them up, but I think they're not that would be a great deal. and the other one is for this particular project, I think we only need 10 or something. I mean, we're doing a proof of concept, but if we wanted to have them in every room on campus, then we might need 5,000 or something. I think that's probably about how many rooms are on campus. I really don't know, but I would take that number way down because it's going to terrify everyone.
Okay.
And let's see what else was it. Oh, the other one is there's probably a good time to declare this, and you might just put a slide in to say there's 3 different kinds of Alexa service. There's what I would call public Alexa. There is Alexa for business, and there is Alexa for hospitality. And right now we're trying to figure out which one makes the most sense.
Okay.
Because it's entirely possible that we're going to publish one as a general Alexa skill that anybody with an Alexa device can use, because that might be the FAQ. And then we might use Alexa for business only for people that were enrolling in the test that have them in their dorm room, for instance. Make some sort of distinction, because it'll be people that know Alexa will go, oh, wait a second, how are you going to do that? So does that make sense? I mean,
Definitely.
these are all kind of minor comments, but I think you guys have done a great job. By the way, I don't think I did as good a job on the presentation when I was in college, so well done. You guys are way ahead of where I was. That's easy to read, easy to understand. Let's see, any questions for me or thoughts or anything? I think you guys all should now be enrolled in the GitHub site. I suspect next week when I'll be back in person, we should maybe get you guys an intro to just the AWS services. I don't know if you guys have taken the tutorial yet on AWS, but it might not be a bad thing to just have you guys sign up for a Cloud Guru. It's free for the first 30 days, and just kind of go take their intro to, they have an intro course, it's about 2 hours, that is on developing an Alexa skill. So that might be a good thing to do. Once you've done that, let me know, and then I can get some time with you guys next week, maybe Wednesday or Thursday, and answer any questions in that, because that will answer a lot of the questions that you probably still have about developing that skill and publishing it to GitHub and all that. That sound good?
Yeah.
So I actually had a question about encryption. So what?
A little bit closer. Sorry, I'm just having a hard time here. Yep,
Okay,
no worries.
so my question was about what exactly we're encrypting. So I had thought we would be encrypting the PIN that we would send through the text message. But is there anything else we have to encrypt?
Well, so here, I don't know the answer to that, but here's some advice. There's a guy named Werner Vogels, who's the CTO of Amazon. He has a very famous quote: "Dance like no one's watching, but encrypt like everyone's watching." So the simple rule is anything you can encrypt, we will encrypt. And if we look at S3, which is going to be our data store probably, we'll basically choose to encrypt everything that is stored on the system, and we'll secure the private key in the vault. And I'll work with you guys on that, because the simple answer we want to be able to tell everybody is we have data that we can't get access to. So if it fails, you can self-correct. So when the student enrolls and they put the wrong phone number in, they could go back and change that, but we can't. So we won't know what their student number is, and we won't know what their phone number is, because we won't actually be able to look at the encryption. It'll be a one-way encryption. And for the purposes of this conversation, I'll probably hold the key or give the key to your professor or something like that. We'll literally put it on a USB drive and delete it, so that we can show from an audit trail point of view that none of us can actually look at the data. By the way, not that it is terribly interesting, but it's just a good best practice that I want to teach you guys about security, right? So, so the simple answer is, from a design point of view, assume everything's encrypted, although the reality is the OTA, the over-the-air authentication, I don't think it actually can be encrypted when it shows up on the phone, because there's no key to decrypt it, so it goes as plain text to the phone. But at that point, we've already established that the student ID matches the phone number, and the phone number is getting the OTA via unencrypted SMS channel, which is totally okay, but that should be fine. The other thing is the budget piece. Just one more thing is, the budget piece probably should be a specific ask. So here's what we need right now. For Andreas, we need this, this, and this that are going to cost money, because we actually need to go provision that in an Amazon account. No, right now I'm just paying those costs out of my back pocket, but we want the university to do that, because assuming this becomes popular, I don't really want to subsidize the university. So, let's see. And then, Emily, why don't you talk to Chris about becoming the administrator of the GitHub site? And we may want to reset it up, because you guys definitely need to have administrative privileges there. You'll reset it up, and then I'll go back and add it as a pro account. We'll figure it out, but work with Chris on that, because I don't have the time to do it this week, and I want you guys to get in there and start be able to sling code if it's not working. Okay? So,
Yeah.
make sense?
Yes.
Anything else from all of you wonderful people?
Yeah, I was wondering if you, if Andreas knows about our presentation today.
I don't know if he does. If you let him know, he may or may not be able to come, but definitely record it. And what I would do is actually open up a Zoom session like we have right here on your own free Zoom account. Each of you just open a free Zoom account. It doesn't cost anything, and it's 30 minutes for free. And then record that session so you can share it back with Andreas and me and everybody. Just as a general best practice, it's a really nice thing to have for your portfolio later. So, but if you send him the message, maybe just one of you, and copy me on it, he'll know. But it's going to be like, for me, I think it's going to be 2 in the morning or 1 in the morning, something like that. So it's pretty unlikely, but you can go ahead and send it to me, and if I'm awake, I will join. So
Okay, I'll get that set up.
cool. All right, guys. Anything else? Are we good? You happy?
What did you say you wanted to add to the budget slide? I was a bit
Well, I
confused
turned
when
it
you were
into
saying.
a budget that sort of says on the right-hand side, this is what we think we're going to spend each month, and we need some money from Andreas, who's the central sponsor. I mean, Lambda, by the way, is 1 million uses per month for free, so you probably don't need anything there. I would investigate your costs on SMS more and look at the Amazon costs. I think even though they cost more than Twilio, it's probably going to be better, honestly. And then the Amazon Echoes, you already have all of the Echoes you need for this trial, so I wouldn't put that as a benchmark. So it's probably not very much money. It's really just text messages we plan to send. And we're probably going to send that to a constrained bunch of people, right? Like we're going to probably have 10 people enrolled as test users, maybe 20 or something like that. So it'd be surprising if this thing hit more than $20 a month, is my guess. But we might learn. It could cost more than that. If we're doing Alexa for business, it's like $7 a device a month. So then suddenly, that's a whole lot more. And so put that in. It might be Alexa for business, and I think it's $7 a month per device, which is that's real money. So, good. Okay, I'm going to, unless there's anything else, I'm going to stop the recording and share it back to you guys. And for your presentation tonight, I guess it's early morning there for you guys. Good luck in your presentation. Do what you just did, and you'll wow them. So well done, team.
Thank you.
Thank you.
All right, guys. Take care.
Thank you.
Bye-bye.
Bye.